Okay, what we're going to do here is we're going to take a look at slightly soluble materials. And the most soluble of the slightly soluble materials is silver acetate. And silver acetate is actually, for something classified as slightly soluble, quite soluble. And you can have the students check the KSP of silver acetate by reacting a saturated solution of silver acetate with copper wire, if you can afford the silver acetate. So what we have done is created a saturated solution of silver acetate. Now, being saturated, there will be some silver acetate solid floating around in here. And so before you actually put some silver acetate into a beaker, you're going to have to filter it to make sure that there is no solid silver acetate in there, because you just want what's dissolved. So we're going to take 100 milliliters, that's 0.1 liter, of the silver acetate solution and pass it through a filter funnel and obtain 100 milliliters of the solution. Slightly over 100 milliliters. Just take that down. And we'll put it in a beaker. And we're going to put a copper coil into the beaker and allow the silver copper redox reaction to take place. The copper will become coated with silver, and the copper metal will dissolve into the solution.
Mrs. Zemer,
to show you what happens
2051, Mrs. Zemer,
if you have excess
This is waiting.
silver acetate, what I'm going to do is put in 1/100th of a mole, that's 1.67 grams of silver acetate into this beaker to start with. And we'll see what happens with this, but we'll set it up the same way with 100 milliliters of silver acetate solution in the beaker as before in the copper coil. Exactly 1.67 grams. You can read that, the formula mass, right off the labels, so you don't have to do a calculation. And again, I'm going to take 100 milliliters of the solution. Filtered, of course. Got it right on this time. and carefully pour it in to try to wet the silver acetate so that it stays within the solution. So we've got solid silver acetate here. And again, we're going to set up a copper coil into the solution and see what happens. Okay, this will take a day or two before we can come back to it. Okay, here we are 2 days later, and you can see that a reaction has occurred, that silver is indeed around the copper coil. The copper has dissolved into solution, but there's a difference between the two. You can see one is much darker, one has a lot more silver in it than the other. The darker blue, this is where we added the 1.67 grams of silver acetate. So more silver has gone around the coil and more copper into solution, giving the darker solution. So what happened? Well, as the silver ions are pulled out of the solution, it's created a shift in the equilibrium such that it's now deficient in silver ions. To replace the silver ions, the solid silver acetate began to dissolve, even though technically no more was to dissolve. So according to Le Chatelier's principle, if the silver is removed, more silver acetate will dissolve into the solution. And this has to be known because if you understand that concept, if you think of dumping different materials into the environment, if a certain amount of the material is removed through some process, then more of it is just going to enter that environment. As we see here, the silver has gone out. What I am going to do is I'm going to knock the silver off the copper coil. I will wash it all off, filter and wash this, and then we'll take a look at how much silver we actually get. Okay, I'm not going to do that here. I'm going to do that behind the scenes, and we'll come back and take a look at the amount of silver that we did obtain from the saturated solution. Okay, just adjusting the balance for the filter paper, and we've got the filter paper and the dried silver here, and this comes out to 0.78 grams of silver that we've collected. Now, in doing this, you can end up slightly higher because of temperature effects, slightly lower because you lost some silver left behind on the copper coil or in the beaker that you started with, or you could end up higher because there's some copper that came off with the silver as you try to get it all off. But we have 0.77 grams of silver. We can convert that to moles of silver, take the moles over the volume to get the molarity of the silver ions. Molarity of the silver and acetate ions were the same, so if we take and square that molarity, we will have the KSP of silver acetate.